how do you make, provided that your tools are accurate, right? How do you make a perfect 90-degree angle without, only with a ruler and a compass, without like any right angle, pre-made angle tools or anything like that? So we have a ruler, we can draw lines. Compass, we can take a point and draw an arc. Okay? So you take a compass here, and you draw arc up here, and you draw arc down here. You take another point, right? Then if you connect, so this is obviously not accurate. If you connect those two, right? It's like intersecting two circles, right? And the two circles always intersect here in a perfect 90 degrees with the radius. Okay, so this is a perfect 90. Once you have that, you get your compass again. You pinpoint it there, and you fix a point on the line. Okay, so you draw. So it's here. It is. You know that. So then you just go here, and then you just draw the same mark on this side. And then what you have here and here is equal length, and it's 90, right? So then you just finally connect those two dots, and that's a 45, 45, 90-degree triangle. Okay, so we can make it. Are you convinced that we can make it? If someone were to ask you in the future, make a perfect right angle triangle, you can make it. Okay, so let's say we have the 45 now, 45, 90 degree. And the nice thing about this is that it's an isosceles triangle. So again, because we're going to take ratios, let's pick a convenient length. And it's 1. 1 is, you can't get any simpler than 1 here. 1, and by Pythagorean theorem, this will become root 2. So what is sine of 45, cosine of 45, and tangent of 45? Good. Reading it right off, we get 1 over root 2, 1 over root 2, and 1. Now just a note about 1 over root 2. 1 over root 2, we can actually multiply that top and bottom by root 2 and get root 2 over 2. Okay, so sometimes this is better to use, sometimes this is better to use. Let me give you an example when this is better to use. If I ask you to add, for example, sine of 30 plus sine of 45, the ratios, sine of 30 is half. Sine of 45 either can be this one or this one. Which one do you think you should use? Second one is better because it already has a common base. So it's simpler for us to simplify the expression. Okay. So let's summarize what just happened. Okay, so let's make a little table here. Okay. So let's say sine, cosine, tangent, and let's say 30, 45, and 60. So let's just fill out the table with the information we just found. Sine of 30 is half. This is 1 over root 2. This is root 3 over 2. This was root 3 over 2, 1 over root 2, and this is half. 1 over root 3, 1, and tangent of 60 was root 3. Okay, so let's just point out some patterns here. Note that because we're in the same right angle triangle, look, these are opposite angles, right? These are complementary angles. They add up to 90. They're on the opposite end of the, right? This is 30, this is 60. So for that reason, sine of 30 and cosine of 60 is the same. This is also same. And of course, the two middle are the same. Okay, note that these two are reciprocals, and this is very easy, 1. Now, tangent is actually sine of theta over cosine of theta. Okay, if you look at the pattern here among the numbers, look, what's 1 over 2 divided by root 3 over 2? What's 1 over 2 times by 2 over root 3. You get exactly 1 over root 3, right? These two are exactly the same numbers. If you divide it, you get 1. Right? Sine of 60, so that divided by that, root 3 over 2 times by the reciprocal. Do you see that gives you root 3? So this seems to work. But more generally, look. Let's call this A, B, C. Sine of theta, this angle theta here is B over C. Cosine of theta is A over C. What happens if we do, okay, so if we do sine theta over cosine of theta, we have B over C divided by A over C, which is B over C times by C over A. Look what happens. B over A, right? What's B over A in this triangle? That's tangent of theta. So it's always true. So it's a very important one to remember. Tangent of theta is sine theta over cosine of theta.